Okay, so in this step, what we're going to do is we're going to take the data we created in step 2, which is here, and we're actually going to define the projection and reproject it. And I'll talk about what that means in a second. So if you recall, we went from a CSV file, read it into ArcMap, took the CSV using the latitude and longitude, read it into ArcMap, and converted it or exported it back out to make the January demo data. Now this data set looks like it's ready to go, but if I move my cursor over here, you'll see in the lower right down here that the coordinates don't look right, and it doesn't really know where it is. There's no projection. We can't really work with this data set the way it is. We will get a lot of errors if we try to do any analysis. We can look at its table though, make sure we didn't lose anything. So I'm in the preview mode again. I'm looking at my January demo data. I'm looking at the preview tab here, and I'm just looking at the table, so I can go between the table and the picture. Looking at the table, it doesn't look like we lost anything. Nothing's been truncated or chopped off up here, so it looks good. Go back to the picture view. What I'm going to do is take a look at this January demo data set and look at some of its properties. So over here on the catalog tree, come back over and find it. And if yours is all closed up again, or you don't have a folder connection, you've just relaunched our catalog, you see it looks like this. Click on the plus sign. Click on the plus sign for your folder connection, in this case demo data. Look at my data. And again, just think of this cylinder as another folder. It's just a weird way to show a folder in the software. Click the plus sign, and you'll see there's our file. I'm going to right click on it. I'm going to get a quick menu. And I'll kind of jog past the rest of these here and go right down to its properties. And in the properties, you get some very general information about it. A lot of different things here. I'm not going to focus on those. I'm just going to look at the coordinate system. And you can see that down here, this file has no known coordinate system. It's not sure where to go in the software. Again, you don't ever want to work with your data in this state. This can throw all kinds of errors and just become a general headache in ArcMap. So I'm going to cancel out of this. And what I'm going to do is actually do a two-step process. The first step is to define the projection. And that basically allows your software, your data, to know where its origin point is. Remember, what we're trying to do is get this data set onto a Cartesian plane so we can work with it and measure. So what we're going to do is first define it, get its 0, 0 point, as I like to call it, and then project it so that we're no longer thinking about this data set as 3 dimensions and angles, and we're actually going to be able to think of the software will be able to think of it as measured distances. So to do that, and this is I'm showing you a lot of shortcuts here. If you come up here to the toolbar, underneath the word Customize where I launched ArcMap before, I'm going to move down a couple to this tool called Search. I'm going to click on that, and what this does is allows me to search all the toolboxes in this software. You can do it here too. You can click on Tools and then go into System Toolbox. You see there's a lot of toolboxes here. A lot of things are buried in here, and it can become kind of difficult to navigate. So I'm just going to open the search box, it's over here, and I'm going to make sure I come up here and click on Tools. So I'm going to be searching all the toolboxes for what I need. In this step, I need to define the projection. And you can see you get a couple of different choices. We're not going to talk about mosaics. We're not going to define overviews. We don't want to define projection for a coverage. This should, in my opinion, should be taken out of the software. This is a very old file format from about 20 years ago, and it always confuses people, so skip it. And go right down to the bottom here. This is the one we want. Define projection in the data management folder. I'll click on that. Unfortunately, it keeps returning things we don't want, but right here in the first choice, define projection data management. That is the tool we want to use. Click on that. And you're going to get your input, a couple of different things you need to fill out. Your input data set or feature class, that'll be this. And then we're going to have to choose a coordinate system to start with. So the first thing we're going to do is come over here, and this is like why I like to work in our catalog. It becomes a click and drag event. Here's my data. Click and drag it right in there. Drop it in. You don't have to go hunting and pecking and trying to find it. it says it's got an unknown coordinate system, so we need to correct that. We're going to click on this button that really has an icon that I'm not sure what it's ever meant, but we can click on this button, and we're going to be presented with the Spatial Reference Properties dialog. So the first thing we want to do is we're going to do a geographic coordinate system. When you define the projection for a data set, you always start with the geographic coordinate system folder. Do not jump to the projected. Don't go here. This will actually corrupt your data. So start with geographic coordinate system, click on the plus sign, and you'll see there's a lot of different geographic coordinate systems to work with. What you can see here is that it's labeled by region of the world. We're going to scroll down until we find North America. Click on that plus sign, and we're going to have a lot of options in here. So I'm going to scroll down. And usually, it's safe to assume, because this is federal government data, it's going to come to us in either an NAD 83, or it can come to us in a WGS 84, which is down here at the bottom. Or no, it's not here. You can see the different types. I'm going to choose NAD 83, North American Datum 1983. You can see there's an NAD 27. NAD 27 is based on surface measurements only. That put the 0 point of the United States at the center in Kansas, because it's based on surface measurements only. NAD 83 is an updated version of this, which approximates the center of the Earth. Click OK. So what we're going to do is we're going to define the projection for this January demo data set to the GCS North American 1983. Geographic Coordinate System, North American 1983. Click OK. The tool will run, and what you'll find with this software is it'll either scroll down here in the lower right, and then down here you'll actually get either a green check mark telling you it was successful, or a red X telling you a tool failed. In this case, the tool was successful. Close it. Come back to your January demo data, right-click, and go down to Properties, and you'll see now it's defined. Its XY coordinate system is NAD 23. Okay, good start. Okay. The last thing we need to do at this point is we need to project this data. We can work with it in this state. The software will be nice to us and do things on the fly or as needed. But I like to take the next step and make sure I project this data, and it's a best practice to do that. That way you know your data sets have been properly formatted and can be ready to go to be dropped in any project. So I'm going to come up here to this box, and I'm going to type the word project. In this case it's project. A little confusing. And you'll see you get several options for projections. Again, you want to use project and data management. That's what we're looking for. This is not a raster data set. This is just a vector data set, so we're doing project data management. This is the choice we want. Again, the search is not always so clean. It tends to return a lot of miscellaneous things. But you can see it says project data management, and we can choose that tool. The toolbox will open, and what we will do is we'll fill it out. Everywhere you see a green dot, if you didn't pick it up the last time, required information. So our input data set is the same data set. Okay, remember this is the second step. We told it had where its 0 point was for Cartesian purposes. Now what we're going to do is go to make an output. And notice here it's going to go to the same location. Demo data folder, the data folder, January demo data, geodatabase. And here's what it's going to be called. Sometimes this tool isn't as cooperative. If you need to find it, same process. Click on this little folder to save it in the proper location. Drop down. Use your folder connections you created in the first video. Go to your demo data, data, January demo data. And what we're going to call this is January demo data PRJ for projected. And what we're going to do is use a continental projection. So we'll click Save. And now we're ready to choose what our projection is. It's the last piece of information here. So click on this again. It's the same button, and it's going to open the same dialog, which often confuses people. So what we're going to do is we're going to choose a projected coordinate system. This is very confusing to look at because looks like you're in the same spot, but you aren't. Click on the projected coordinate system, okay? And because this data set covers an entire continent, we're going to use the continental. So you can see here we've got all these different types of projections we can do. Because we know our data set encompasses all of North America, parts of Canada, and Alaska, we're going to use a continental projection. That will actually project the data in a way that makes sense for data sets that span that much distance. Click continental. Again, you see we've got some different continents to choose from. I'm going to click North America. And what we're going to actually choose here is a North American Lambert conformal conic projection. North America Lambert conformal conic. Did some research on this. This seems to work the best for contiguous state, 48 states, Canada, and Alaska. Click OK. Now we're ready. It's all loaded up. Click OK. And you can see down here the projection is now running. We're projecting the data set successfully. Green check marks. And now if we come over here and look at our projected data, you'll see that it looks slightly different than it did before. You can click on both data sets now and compare the change. I'll right-click the projected and look at its properties, and you can see now it's been projected to North America Lambert conformal conic. From there, we can now work with this data set to do some analysis.